any applications where we can see heat exchanger? Anyone?
The car radiator.
Car radiators, excellent. What else?
The refrigerator.
Refrigerator, very good. Jayad. And anything else in home like geyser? Geyser is also a heat exchanger. Then if we look
AC
at
com
the the,
AC.
the AC, bilkul. AC, we have got evaporator and condenser, so that is also a heat exchanger. And then if we talk about industrial applications, there are many like boiler, like condenser, and then in like Stirling engine we have got in gas power cycle we have got heat exchangers like condenser and then evaporator. So we have got in abundance the heat exchanger. If I would say that we can see it everywhere, like in engineering applications as well as in home applications. So, uh, what is a heat exchanger? So, heat exchanger are practical devices which are employed to transfer heat energy from one fluid to the other fluid, right? So, it is not like the system surrounding interaction. It is a kind of the interaction of heat between two flowing fluids. Now, heat exchanger, where do we see them? They are being used for the condensation of vapors, like in condenser of steam power cycle evaporates liquid like we do it in boilers, then recover heat to use elsewhere like regeneration phenomena which we studied in thermodynamics too, then reject low grade heat uh, somewhere in the sink like rejection of heat in lakes or maybe rivers or in air. So uh, application of heat exchanger includes steam gas power cycle as we discussed and refrigeration cycle. So it is just a schematic of steam power cycle. So we know that feed water heater which is used for that regeneration phenomena. So I just thought that we can put a figure here and then uh, now we know that what is heat exchanger. We can discuss different types of heat exchanger. The simplest one which we can think of that we have got two pipes. One is of bigger diameter and the other one is of smaller diameter. So we put the smaller diameter pipe inside the bigger diameter pipe, and then we would have one fluid which is going to pass through this blue pipe which is of smaller pipe, and then the second fluid would be passing through this annular space between and the smaller pipe and the bigger pipe. So it means that we would be seeing some this red area. So that is the annular space in which we would have the flow of second fluid. Now they are concentric pipes basically. So we call them double pipe heat exchanger. But usually in practical application, we seldom see them in this arrangement. Rather, we see them like a bundle of tubes inside uh, a bigger shell. Like that shell can be of cylindrical shape. So, if I can show you that practical uh, way in which these smaller pipes are arranged. So now you can see a bigger shell outside, and then you can see a number of tubes within this bigger shell. So we call them shell and tube heat exchangers usually. So it means that whatever there would be one flow of a fluid which would be passing through these small tubes, and the other fluid would be coming from here in the bigger cylinder. We also call it shell, and then you can see certain here circular structure here. So we call it baffles. So the function of baffles are two types of functions. One of that is to support these smaller tubes, and then the second.
एक्सक्यूज मी सर
Yes.
सर एक इस कोर्स सेट के क्वेश्चन था सर रिलेटेड इसी से था सर वो एक कल क्वेश्चन पूछा था किसी दोस्त ने सर तो वो पूछ सकता हूँ अभी आपसे
Maybe afterwards, maybe at some one-to-one discussion.
सर अभी बता दें
तो मैं आपको बता तो दिया है कि अगर वो इस कोर्स से रिलेटेड नहीं है, देन
सर रिलेटेड
वी।
इसी से है
अच्छा
सर कोर्स आप नहीं पढ़ाया आपने
जी, बताइए, पूछिए।
सर एक सेकंड में क्वेश्चन सर एक सेकंड में क्वेश्चन निकाल लूँ एक सेकंड
आप कौन है वैसे, क्या नाम है आपका? आतिफ।
आतिफ सर यस सर
अच्छा, ये आई होप कि कोई ऐसा क्वेश्चन नहीं है जो कि आपकी असाइनमेंट का हो
नो सर असाइनमेंट का नहीं है सर
या प्रोजेक्ट का हो कोई।
नहीं सर
जी
सर क्वेश्चन
बताइए।
द प्रोसेस वेयर एयर एंड fuel are burned which results in temperature increase is called
सॉरी।
सर प्रोसेस कौन सा होता है जिसमें एयर और फ्यूल मिक्स बर्न होते हैं और रिजल्ट इन टेम्परेचर इंक्रीज
ठीक है, ये क्वेश्चन क्या है इसमें, ये उस प्रोसेस का नाम आपको नहीं मालूम?
यस सर कंफ्यूजन हो रही है सर इसमें
क्या कंफ्यूजन है? कंफ्यूजन बताए पहले, क्योंकि ये तो काफी स्ट्रेट फॉरवर्ड सी बात है। कंफ्यूजन क्या है?
सर हीट रिजेक्शन एक्सपेंशन हीट एडिशन इनमें
जी।
से कौन सा होगा इनमें से कौन सा होगा
अच्छा, ये मल्टीपल चॉइसेस एमसीक्यू है क्वेश्चन?
यस सर
कौन कौन सी चॉइसेस हैं बताएं?
सर एक सेकंड सर हीट रिजेक्शन
ठीक है।
एक्सपेंशन हीट एडिशन
हीट एडिशन ही लगता है, क्या ख्याल है? हीट
सर
एडिशन
हीट
तो नहीं होना
रिजेक्शन
चाहिए, हीट जनरेशन कह सकते हैं इसको आप, या
सर हीट
कंबस्टन
रिजेक्शन और
प्रोसेस है ना?
एक्सपेंशन
ये
सर
कंबस्टन प्रोसेस है ना बेसिकली जो आप बात
यस
कर रहे
सर
हैं। ठीक है,
यस सर
तो हीट एडिशन स्ट्रिक्टली स्पीकिंग तो नहीं होगा, लेकिन if we ignore that the interaction between system and surrounding, then we can call it heat addition. That is the most closely choice you can choose from the list. ठीक है।
सर एक्सपेंशन
अब
नहीं कह सकते सर हम इसे
नहीं, एक्सपेंशन तो तब है ना कि अगर वो जो ऑपरेशन हो रहा है वो किसी पिस्टन सिलेंडर अरेंजमेंट में हो रहा हो जिसके अंदर पिस्टन मूव कर सकता हो। If that combustion is happening in some environment where it is just to create hot gases, फिर उस केस में तो आप उसको नहीं ना कह सकते एक्सपेंशन। एक्सपेंशन तो तब होती है जब कोई वो पिस्टन सिलेंडर अरेंजमेंट हो, उसके अंदर जब कंबस्टन हो। ठीक है।
यस सर
अच्छा जी, थैंक यू
थैंक यू
फॉर
सर
आस्किंग दिस। लेकिन मुझे अभी तक समझ नहीं आई कि इसका हीट ट्रांसफर से क्या ताल्लुक है, लेकिन मे बी यू नो बेटर अबाउट दिस। ओके जी, सो वी हैव डिस्कस द डबल पाइप हीट एक्सचेंजर। द सिंपलेस्ट assembly is concentric pipes, and then the practical way in which this double pipe heat exchangers are usually used. So we have got a bundle of tubes which is inside big shell or cylinder, and then I talked about that these supporting structures, you can see these circular bodies here. So 1, 2, 3, 4, 5, we call them baffles. So baffles, the function of baffles are basically two functions. One is to support these smaller tubes, and then the second one is to make the flow which is going through this bigger shell, to take it turns, like it would go this way, zigzag motion. So in that way the contact between the shell fluid and the tube fluid would be more and more. So we would be talking about this in detail in the coming lectures as well. So now in this double pipe heat exchanger, for the flow of fluids, we have got two options.
एक्सक्यूज मी सर
जी।
सर ये जो आपने बेफर का फंक्शन बताए थे आप बता रहे थे या बताए थे दो वो कौन से
जी.
थे अगर रिपीट आप कर लें?
Yes, one is if you look at the figure carefully, you can see these tubes passing through baffles, right?
जी
So
सर.
it means the first function is to support these tubes so that they don't bend or they don't structurally fail, right?
जी सर.
And the second one is that the fluid which is coming inside from here, from the shell side, if we don't have this baffle, what will it do? That it would go straight away towards the right hand side. But
जी
now,
सर.
because if there are baffles, it has to go first like this, and then go underneath this, then come up, and then go into the zigzag motion. Let me show you that maybe this one. Can you see this figure?
Yes sir.
Now you can see that the fluid which entered here because of this baffle I was talking about. So first of all, it didn't go into the X direction. So because there is baffle, it has to go up and then it has to come down because there is also a baffle on the top side now, and then it means that it has to go downwards and then again upwards zigzag motion.
Yes sir.
You understand?
Yes
And
sir.
yeah, okay. So let me go back here. So we were talking about the types
Thank
of.
you sir.
No, not a problem. Okay, ji. So now we have got two types of flow arrangement for the double pipe heat exchanger. One is the parallel flow in which both the hot and cold fluids enter the heat exchanger at the same end and move in the same direction. So it means that the hot fluid is also entering from the left hand side and cold fluid is also entering from the left hand side, and then they go out from the right hand side. So that is the first arrangement and we call it parallel flow. So in this the temperature difference is maximum at the entrance because the cold fluid would have the least temperature and the hot fluid would have the maximum temperature. So the temperature difference would be the maximum. So if we see that on the figure on the left hand side, so it shows us the parallel flow arrangement. The second flow arrangement is that if the cold fluid is entering from the left hand side and the hot fluid is entering from the right hand side. Now we have got the second arrangement. So if we and we call it counter flow arrangement. So counter flow is like this. So in the parallel flow arrangement, the maximum temperature difference is in the beginning, and then temperature difference decreases rapidly. So it is kind of that constant temperature boundary condition graph. But here on the right hand side, if you look, that looks like the temperature difference between that solid surface and the mean temperature. So it is kind of that constant heat flux graph. So in counterflow graph, the temperature difference remains almost equal from the on the entire length, but for the parallel flow, the temperature difference decreases rapidly. Yes. Any question? Okay, ji.
सर
I think yes, yes.
सर अगर आप आज का क्विज डिले कर दे सर अगर पोस्टपोन हो जाए अगर आज क्विज
बेटा कौन बात कर रहे हैं?
सर मैं बिलाल
बेटा क्विज तो आज ही होना है। अब पहले कल हमारी ये वी एग्रीड अपॉन दैट, सो वी आर गोइंग टू टेक द क्विज टुडे। ठीक है, क्योंकि ये पूरी क्लास का एक डिसीजन था ना।
सर पूरी क्लास ही कह रही है अभी
नहीं, पूरी क्लास कल नहीं कह रही थी।
सर
फिलहाल
सुबह से वाइवा हो रहा था, हमें तो सुबह 4.5 घंटे का 5 घंटे का वाइवा दी हमने
कोई
सर। अभी
बात नहीं,
सारे
कोई
एग्जॉस्टेड है
बात नहीं,
काफी।
कोई बात नहीं, कोई बात नहीं।
सर आप
नॉट
काइंडली
नॉट
अगर
एन
कर दें
इशू।
सर।
नो, that is not.
Please, sir.
Okay, ji. So we are going to have the quiz in 15 minutes time. So please be prepared for that. So let me continue with this lecture. So the second type is compact heat exchanger. So in this, the heat exchanger having area density greater than 700 meter cube per meter square per meter cube. Now, what is area density here? Area density is the ratio of heat transfer surface area of a heat exchanger to its volume. So it means that we are talking about the volume of that heat exchanger and the surface area available for the heat exchanger. So if I elaborate it, so examples of compact heat exchangers are car radiators in which the this we call it beta. So beta is the area density. So that is 1000 meter square per meter cube. Glass ceramic glass gas turbine heat exchangers, which are of 600 meter square per meter cube. Then the regenerator we have got 15,000, and then the you would be surprised that human lung is also a heat exchanger, and this is the best heat exchanger in terms of surface area to volume ratio. So it means that surface area, because we have got bronchioles, very minute tubes, numerous tubes. So for that, the area density is 20,000 meter square per meter cube. Okay. So compact heat exchangers enable to achieve high heat transfer rates between two fluids in a smaller volume, and they are commonly used in applications with strict limitation on the weight and volume of heat exchanger. So like in the car radiator, we have got fixed volume where we can use that car radiator. So that's why we have to make it compact. So it means that we have got the surface area available in a given volume. It should be very high, and usually we increase that surface area by the use of fins. Fins are the plates which are attached. So in that case, we use fin. So now you are seeing that in the heat exchanger design, we have got internal force convection, external force convection, the use of that radial heat transfer, and then on top of that, we have got the use of fins here. Okay, ji. So in compact heat exchangers, the two fluids usually move perpendicular to each other, and such flow configuration is called cross flow. So now I am going to show you the figures. So now on the right hand side, you can easily see that is the arrangement of flow over a tube bank, which we have studied in chapter number 7. So we have got two options in this. One is in that we have got the flow, the flow of fluid is being separated from each layer by the use of these extended surfaces, which are also called fins. And that is the example of car radiator, where we use those fins. And on the right hand side, that is the flow of air over the ICs in a laptop. Because for the ICs in the laptop, we don't have these fins there. So that is the case where we use that mixed flow. So it means that the flow layers can mix while flowing across these tubes. Okay, ji. So and then shell and tube heat exchanger. So it contains a large number of tubes, as we discussed in the case of that double pipe heat exchanger. And then I also discussed about the function of baffle. So you can see here that these vertical black lines here, 2, 3, they are baffles. So one function of that baffle is to support these tubes, because they cannot. These tubes need some support to be in this shell. So they also provide that support, and as well as they also give us the that more surface area for the heat transfer by the zigzag motion of shell side fluid. Okay, ji. So heat transfer takes place as one fluid flows through inside the tube while the other fluid flows outside the tube. So baffles are commonly placed in the shell to force the shell side fluid to flow across the shell to enhance heat transfer and to maintain uniform spacing between the tubes. So that is the purpose of supporting those tubes. So not suitable for aircraft and automotive industry. So that's why shell and tube heat exchanger are usually used in places where we have stationary application like a steam power plant. We usually use boiler in that, so those are the things where we usually use shell and tube heat exchanger. And this is a schematic of maybe a 3D view of flow of shell side fluid. So we can easily see that vapors force the shell side fluid to move in a zigzag motion. अच्छा जी. And then shell and tube heat exchangers, they can be classified further by the number of shell and tube passes. So if we have got uh, shell and tube heat exchanger in which the tube only takes one turn, so it means that we would call it one shell pass and two tube passes. So it enters from here and it goes out from here. But if we put a baffle in front, now we have got two shell passes and four tube passes. And if we keep on putting those baffles, then the number of shell passes and tube passes would increase accordingly. So why we need that? Because we need to calculate those heat transfer. So in that, some correction factor is required for these multiple shell passes and tube passes. We would come to that in detail when we would study the heat exchanger design analysis. So one shell pass and two tube passes heat exchangers. So that which is kind of self-explanatory from this figure. We can see very clearly that in this case the shell pass is only one, but two passes in this case shell passes are two and tube passes are four. Okay, ji. So the overall heat coefficient we already studied in case of in chapter number 3. So it gives us the combined effect of convection and conduction resistances, and we can also include radiation resistance if required. But for the heat exchanger design, predominantly there is convection and conduction. Conduction is if we see that concentric double pipe heat exchanger, we have got a fluid passing through the inner tube, so it means that there would be a convection inside the fluid, and then when it the heat would be going to be transferred in the radial direction, we would have conduction resistance on this uh, cylindrical thickness, and then in the annular space we have got the other fluid, so it means that we would have another convection resistance for this fluid which is going outside this inner tube. So the total resistance would be circuit in series. So it would be having one resistance for the inner fluid, convection resistance, then conduction resistance for this, and then again convection resistance. Okay. So and we also know that for the series we just need to add them. So we have got convection resistance like this. Then conduction resistance we know in the radial direction, that is natural log of d outer upon d inner. D outer is the outer diameter of this inner cylinder. So outer diameter of this inner cylinder, and d inner is the inner diameter of this inner cylinder pipe, not cylinder, and 2 pi kl. So we remember this formula from chapter number 3. And if we want to calculate U, we know that our total resistance is equal to 1 upon U into AS. Now, because the area that depends upon the diameter, so usually U value is AI is not equal to A outer if we have got fins as well on the outer surface or the inner surface on the gas side. So, but if we ignore those fins and we say that this cylinder thickness is this pipe thickness is very negligible, then we can say that the conduction resistance is very low because the thickness would be very less. So it means that this natural log of d outer upon d inner, this value would be very small, and we can also assume that k value is very large for that tube because we want to have maximum heat transfer between the inner and outer fluid. In that case, we can simply write U is equal to this. and then if there is a fin, then we can use this uh, surface area of the fin, and we know that we did all this in chapter number 3. So U value for different types of heat exchanger which are used in industry, they are given in this table. So if you look at the values, so whenever we would have some kind of phase change process, in that case the steam condenser light. So in this case, U value would be quite high. So and then in other cases, if there is a gas involved, then the U value would be accordingly. It would be like water to oil. It the value is low because but for the gases because the H value is lower, so U value would be more in that case. So that is the case we can see here. So we are going to restrict ourselves up till here, and we would be going for the quiz number 5 now. So please prepare your